Welcome to Brain Vision.
200 bullets collide with a wall in 10 seconds. Each bullet has a mass of 5.0 times 10 to the negative 3 kilograms, and it collides at a speed of 1,200 meters per second. Now we are asked to find the average momentum, the average change momentum per second. So let's find that average momentum, or the change momentum, I should say. The average change momentum, delta P, is equal to the number of bullets times mv final minus mv initial, and we know that m, or the final velocity, is 0, right, because it collides into a wall. So therefore our average change in momentum is just 200 bullets times negative the mass, which is 5.0 times 10 to the negative 3, times the initial velocity, 1,200 meters per second. And we also want to divide this by 10 seconds, because we are asked to find the average momentum change per second. So therefore our change momentum per second is equal to negative 120 kilograms meters per second, and then this is per second, right? So per second squared, essentially. Now for part B, if we want to find the average force exerted on the wall, we know that the average force, which I'll just write as F average, is equal to the change of momentum for delta change of time. And this is essentially exactly what we calculated in part A, right? Well, we got change momentum, and we know the momentum changes by 120 kilograms per second, and we know our delta T is 1 based on this, because remember we already have momentum per second, and so our momentum is 120 per second. So our average force exerted on the wall is just 120 newtons. Now, part C, we need to find the average pressure the bullets exert on the wall. And so this average pressure, P average, is equal to the average force, right, over the area exerted on the wall. So let's just plug in these numbers. So average force calculated from before is 120 newtons. The area on the wall is given, and that's just 3.0 times 10 to the negative 4 meters squared. And so our average pressure exerted on the wall is equal to 4.0 times 10 to the 5 pascals.